So I wanted to do just a few examples with a cylinder where we're actually finding some number answers. In the previous video, I just wrote down what the formula is, but I wanted to show you actually using it. So let's say that we've got two different cups. So you got a cup that's kind of tall and skinny, and then another one that's more short and wide, like this. So let's say that this cylinder over here is 10 centimeters tall, and let's say it's 4 centimeters across. And then we're going to make this other one half as tall, 5 centimeters tall. And let's make it twice as wide, 8 centimeters across. And so, what I want you to think about is if we filled the cylinder on the left all the way up with water, so if we put water all the way in it so that everything was filled up with that beautiful blue water, and then we poured it in here, would it fill it up perfectly? Would it overflow, or would it not fill up the thing at all? And then after we think about the volume, we're going to think about also just the surface area. Imagine we had to paint the outside of this. How much surface area would that take? Okay, so volume, our formula, and if you watch that other video, I kind of showed why this makes sense, but basically pi r squared tells you the area of one circle, then you multiply by the height, and that's just stacking up a bunch of circles to fill in the entire space. So the volume of this cylinder is pi times 2 squared times 10. And I want you to notice I used 2 instead of 4 because I told you 4 was the diameter. So I could use an exact answer here, or I can use a calculator. 5 times 2 squared times 10, right there. Hit enter, and my volume is 125.66, and this is measured in cubic centimeters. The volume of, so I'll call this the volume of the tall cylinder, VT. The volume of the short cylinder is pi times 4 squared times 5. So think about, what do you think is going to happen? Is it going to be bigger, smaller, or equal to what we just had? Pi times 4 squared plus 5. The volume of the small cylinder is, oops, I don't need to write pi anymore, is 251.32. 33. And it turns out that this answer right here is twice as big as the tall cylinder. That the tall cylinder times 2 is equal to the short cylinder. And this is something that's kind of interesting. I want you to think about, why is that true? That I made it twice as wide and twice as short, but I got twice as big of a volume there. I think that's kind of an interesting thing. So those are both measured in cubic centimeters. And one way to think about why that is the case is because if you look back at your formula, your radius is squared. So when I made my radius twice as big for my short cylinder, that twice as big gets squared to make it a 4-time impact on the volume. And so if I made this twice as big, but I only made this half as big, then I have a times 4 for the radius squared, but only a times half for the height. And so my volume is going to double because half of 4 is 2. So you can think about how when you have different sized cylinders, changing the radius is going to make a bigger impact. It's going to square in its impact, where changing the height is only going to impact it by the same factor that you changed. Now let's look at just the surface area of them. And I'm going to be a little tricky here because the surface area formula is slightly different than what we're going to use. Surface area formula was 2 pi r h plus 2 pi r squared. And that's the formula because basically you're thinking about this right here is the circumference times the height. That's that rectangle you get if you unwrap it. And then this is the top and the bottom circle. But I wanted you to think of these as cups. And so instead of them being top and bottom, if I think of it as a cup, there's really only one of those circles. So if I'm going to paint the outside of these, my surface area formula is going to look slightly different here. The surface area for the tall one is going to be 2 pi times 2 times 10 plus pi times 2 squared. What changed? I went down from 2 circles to just 1 circle because I'm just thinking about painting the bottom because I'm thinking of it like an open cup, open topped cup. And so then that ends up the surface area of the top. You can type all that into your calculator as one long thing, 2 pi times 2 times 10 and plus pi times 2 squared. Oops, I typed in the wrong thing. Trying to talk and type at the same time. I get 138.23. The surface area of the shorter one is going to be very similar. 2 pi times r times h plus pi times r squared is going to be very similar. Try to predict again. Do you think this is going to be bigger or smaller or equal? It turns out again to be bigger because just like before, we are using the r squared part. So changing the r is going to have a bigger impact than changing the h, changing the height. It does turn out, however, that this part is equal to this part. And so this is kind of the idea, if you have a piece of paper and if you fold it to make a cylinder like this, sort of folding it hot dog style, that makes one cylinder, but it's not the only cylinder. You could also have folded the paper in this direction, making it, I guess this would be more hot dog style, folding it along this way, and that makes a tall and skinny cylinder, but they have the same surface area along the curve. So there you go, a couple examples of using cylinders. Thanks for watching. Please comment if there are any questions that you have.